So I had said before that you cannot always just say that the normal is mg. So let's do a couple more normal problems. So normal force problems. So let's imagine we just have two objects, M1 and M2. So M1 is going to be equal to 1.25 kilograms. N2 is going to be 2.22 kilograms. And I want to know what's the normal force acting here. Well, free body diagram, we have N1, and we got M1G and normal 1, because there's a M1 is down here, but there's also a force the M2 pushes up on it. And so that means that Fn1 is just going to be M1G. Okay. And so that's going to be 1.25 times 9.81. So that will be 12.3 newtons. Now, for mass 2, M2, then we've got M2G pushing down. We have normal 2 pushing up. But for every force, Newton's third law, for every force, there is an equal and an opposite force. So if there's a force Fn1 pushing up on M1, M1 pushes down on mass 2. And so that means that Fn2 has to equal Fn1 plus M2G. So it's not just what it was. So you've got to actually include both of them. So that means that it's not just the M2G. So you put all this together, and that comes up to be 34.0 newtons. Okay. Wanted to point this out because this is a common mistake that people make. For every force, there's an equal and opposite force. So forces are interactions between things. And so you have to include this other force in right there. Otherwise, you do not get the right answer.